Hi friends, welcome to Talent Friends Banker's Choice program. In this session, we are going to discuss approximations, which is a very important section in the quantitative aptitude part of bank exams, especially when it comes to exams like SBI clerks. Well, we have already learnt about simplifications in one of our sessions where we have seen how to actually do a simplification using the BODMAS tool and how can we apply smart methods like unit digit method, root digit method, etc. to approach or to get the required answer. And in this session of approximations, we are going to look at how to do an approximate calculation. The weightage of this topic can be anywhere between 0 to 5 marks. As I mentioned earlier, that simplification generally comes for about 10 to 15 marks. So sometimes we see that we get 10 questions on simplifications and 5 on approximations. Or in some cases, we find all the 15 questions on simplifications, right? So approximations also is going to be a very important part in the SBI clerks exam and as well as the other bank exams. So we'll first start with approximations and then we look at some questions from number series. As you all are aware, number series is again an important part of the quantitative aptitude section in SBI clerks exam, but then there is no definite method or formula which can give you the answer. It's all about trial and error. It's all about getting the right idea at the right time. So we'll try to spend some time on number series after we finish approximations. In fact, I'll just take up a few examples and the other questions you just have to try and get the required answers, right? So let's get started with this session on approximations. Approximation consists of various parts, right? In this session, we are going to look at how to find out approximate square roots and approximate cube roots, because sometimes we find that a 1-mark question is given on approximate square root or approximate cube root. Also, in the actual speed math session, you have seen that we have learned how to find out the cube root and square root of perfect cubes and perfect squares respectively. But then to find out the cube root or square root of imperfect cubes and imperfect squares, you need to follow an approximate method. So we are going to look at those methods first and then we'll understand how to approach towards solving a question on approximations. Basically, how do you do a approximate multiplication? What are the do's and don'ts? Or I should say, what are the things which you must not do while following approximations or while doing approximate calculations? So let's first start with finding out approximate square root. How do you find out an approximate square root of the given number? Well, you are already aware of how to find out square root of a number. Yes or no? We have very well learned this in the speed maths video, how to get the square root of a given number. It is a 3-step process and it would take about 4 to 5 seconds maximum, right? Now in this session, we'll look at how to find out approximate square root, right? For example, if the given number is an imperfect square, then how do you calculate the square root of that number? Obviously, we have to calculate an approximate square root. So how do we do that? Right? So let's look at finding out approximate square roots. Now, for example, let's say we have to find out the square root of 8,000. What is the square root of 8,000? That's the question, right? We are doing an approximate calculation. The question says find out an approximate answer, right? And moreover, you know that because the number here is 8,000, it cannot be a perfect square because a perfect square will always have even number of zeros. A perfect square will not have 3 zeros. So it's clear that this is not a perfect square. We will have to do an approximate calculation. And generally in the exams, the heading itself clearly says that you have to do an approximate calculation. We are not required to do the exact calculation to get the answer. So how do we do approximate square roots? How do we calculate an approximate square root? Look at this. This is a very simple technique that you can apply to get the answer here. If you have really understood how to find out square roots, or if you have memorized 1 to 30 squares, as we have mentioned in the speed maths video, it will be very easy for you to get the answer here, right? For example, what is 10 squared? 100. 20 squared? 400. What about 40 squared? 1600. 4 square is 16. So 40 squared will be 1600. How about 60 square? 60 square will be 3600. 6 square 36. 60 square 3600. What about 70 square? 4,900, 80 squared, 6,400, 90 squared, 8,100. So these numbers are already known to us. These squares are known to us. Now, to find out an approximate square root, you first need to understand which is the closest perfect square that you know here. For example, 60 square. What is 60 square? 6,400. Sorry, 80 square. What is 80 square? 6,400. What is 90 squared? 8,100. What is 70 squared? 4,900. So which is the one which you find close enough to 8,000? Let's go with 80 square. Let's look at 80 square, right? You know that 80 squared is 6400. And 90 squared is how much? 8100. Now if you look at the given number 8000 here, clearly it lies between 6400 and 8100. The number here 8000 falls between 6400 and 8100. So obviously the square root should be between 80 and 90. So first look at the options. How many of the options there are between 80 and 90? Let's say there is only one option which is in the range of 80 to 90. You can directly mark that as the answer. You don't have to worry about the remaining options. And let me also tell you that when it comes to approximations, ideally the fifth option will not be given as none of these, right? Generally in fifth option in approximations will never be given as none of this, because we are doing an approximate calculation. If fifth option is given as none of this, we can always mark fifth option as the correct answer, right? However close the answer is in the given options, I can say no, I have a better answer which is fifth option, none of this. So that is the reason it is avoided. Fifth option as none of this is avoided when it comes to approximations. In simplifications we may find it, but approximations is generally not given. So out of the given 5 options, if there is only one option between 80 and 90, you can mark that as answer. But what if there is more than one option, right? Let's say there are 2 options which are between 80 and 90, or all the 5 options are between 80 and 90. Then how do you decide what's the correct answer? Look at this. I know that 80 square is 6400. So let's take 80 outside. Are you able to follow? 80, because 80 square is 6400. We have got 80 here. Now understand, 8000 is how much more than 6400? What's the difference between 8000 and 6400? 8000 difference 6400. It is equal to 1600. 1600. Why are we taking the difference with 6400? Because we have taken 80 as the initial value there, right? We are taking 80. We are starting at 80. So 80, it should be 80 plus something. Yes or no? The answer has to be between 80 and 90, which means it is 80 plus some extra value there. So 80 plus how much is the question now? 80 plus what? Is it 2, 3, 4, 5? Is it 9, 8? What is it, right? How do you decide that? 80 plus the difference of the given number and 80 square. How much is that? 1600. So 80 plus 1600 divided by 2 times the value that we have taken here. 2 times 80 divided by 2 into 80. Just remember, this is simple technique. Take the given number 8000, right? Consider the nearest square that you know. Generally, preferably less than that. So 80 square, 6400. So 80 plus the difference of the given number with the square of the value that you have taken is equal to 1600. That divided by 2 times this value. Now, 1600 divided by 2 into 80. How much is that? This will be equal to 80 plus 1600 by 160. How much is this? 10 times 80 plus 10. So I can say approximate square root is 80 plus 10, 90. 80 plus 10, 90. Now just try to verify. What is 90 squared? 90 squared is 8100. Is 8100, 8000 are quite close to each other. Now you might be wondering, why do we have to do all this? I can directly say that 8000 is approximately 90 squared. Yes, you can do. But then I'm trying to explain you the process here that we need to follow. We'll take up more examples to understand this. But then look at this. 80 is 6400. So that 80 plus, how much is the difference? 1600 divided by 2 times this value. So approximately 90. 90 square, 8100. So very close to 8000. So we can say approximate answer here is 90. Something less than 90. See, understand, generally the answers are not given in decimals. They try to, give the options in integers. So we can easily mark approximately 90 or, 89. Let's say 90 is not there. Approximately 89 can be taken as answer. Out of the given options, whatever is closest, that has to be considered as the answer. Let's take one more example. Let's say we have to find out the square root of 6000. What is the square root of 6000, right? Let me just take the next one. Square root of 6000. How do you do that? What is the square root of 6000? Again, 6000 falls between which 2 squares? 60 square, 3600, 70 square, 4900, 80 squared, 6400. Yes or no? So 60 squared, or sorry, let's take 70 squared. 70 squared is equal to 4900. What is 80 squared? 80 squared is 6400, and the given number 6000 here is between 4900 and 6400. So clearly answer has to fall between 70 and 80. But where exactly between 70 and 80? If there's only one option, we'll mark that as answer. If there are multiple options, then what do you do? Look at this. 6000 has already got 4900 in it, so we can take 70 outside. Are you able to follow? 70 square is 4900 plus how much more? What is the difference between 6,000 and 4,900? 1100. Between 6,000 and 4,900, the difference is how much? 1100. Yes or no? 6,000 minus 4,900. 1100. 1100 divided by 2 times the value that we have taken. 2 times 70. Try to understand. Why do we get 80 here? This 80 is nothing but the value that you have taken. So that is the reason here also 70 is nothing but the value that you have taken. So 1100 divided by 2 into 70. Now try to simplify this. You will get an approximate answer. So 70 plus 1100 divided by 2 into 70 is how much? 140. Or we can say 110 by 40. What is 110 by 14? Approximate, right? Understand, we are doing an approximate calculation. So what is 110 by 40? 110 by 14, 14 into 7, 98. 14 into 8. 14 into 8 is 112. So approximately 8 times. Yes or no? 14 into 8 is 112. So I can say this is approximately 8 times. So 70 plus 8, 78. So approximate square root of 6,000 is 78. Or I can say 78 squared is approximately 6,000. So out of the given options, 78 will be the required answer, right? And understand, you will go for the next step only if there are multiple options. Let's say if there's only one option between 70 and 80, I'll directly mark that as the answer. It has to be 78 only. If there are 2-3 options, 72, 76, 78, then 78 is the best answer. Yes or no? You can verify, you can cross verify. 78 square. What will be 78 square? 78. How do you find out square of a number? We have learned this in speed maths. 50 plus 28. So 2,500 plus 2,800. That is 5,300. 5,300 plus 28 square. What is 28 square? 784. So 5,300 plus 784 will be 6,084. So 78 square is 6,084. Yes or no? Actual 78 square is 6,084. Is it not close to 6,000? Yes. So see how approximate answer we get here, right? How do we get approximate answer? Simple technique here is take the closest square that you know. Not necessarily the closest, lesser or more, but in terms of 80, in terms of tens, what I mean to say here is 20, 30, 40, 50, 60, 70, 80, right? You can go for 85 also, nothing wrong. You can take 75 also. You can start with 75. Even that way it can be done. Let's try. What happens? Let's see. We'll take this one, 6,000 itself, right? Already we have got the answer as 78. Let's see what happens if you take, instead of 70, if you take 75. Because what is 75 square? We have learned how to find out square of a number which ends with 5. 75 square will be 5625. Yes or no? 7 into 8, 56. 5 will give you 25. So 5625. So if at all I take 75 as my base value, right? 75. You know that 75 square is 5625. 7 into 8, 56 followed by 25. Now, if I bring 75 out, right? How much more? How much more than 75? Now look at this. 6,000 and 5,625. How much is the difference? 6,000 minus 5,625. 375. 375. 375 divided by 2 into 75. 375 divided by 2 into 75. How much is this? 75 goes 5 times in 375. 5 by 2 is 2.5. So 75 plus 2.5. 75 plus 2.5 is 77.5. Earlier we had got 88 when we took 70. Now when you have taken 75, you are getting 77.5. So approximately 77.5. In fact, if you try to observe, this is a better answer. This is actually a better answer, right? 78 was 6,084, right? It should be less than that. So that is the reason we are getting something lesser than 78 here, right? But both are correct, because options, as I've mentioned, options generally will not be given as 75, 77.5, 77.6, 77.8. Those kind of options are not given. The options will be 76, 77, 78, and so on. Right? So you can mark 78 there, right? So that's how you go for finding out an approximate square root, right? Let's quickly take one more, and then we'll move to the next part. That is how to find the approximate cube root, right? I'm discussing all this in the beginning itself so that while solving the questions, we don't find it difficult to find out approximate square root or approximate cube root. What is the square root of, let's say, 14,000? It can be any value, right? 14,000, approximately 14,000, or maybe 14,500, 16,800, any value given to you, right? So what is the square root of 14,000? Now, obviously, we have to calculate an approximate answer, right? We can't be finding out the exact square root of 14,000, which is not really possible when it comes to a complex exam. So how do you get the approximate square root? What do? The nearest square that you know, nearest square, preferably less than 14,000, right? For example, 100 square. What is 100 square? 100 squared will be 10,000. You said 100 square is 10,000. This is more than 10,000, right? What about 110 square? 110 square, 11 square is 121 followed by 2 zeros. So 110 square is 12,100, close to 14,000, right? Or if you go for 120 square, what is 120 square? 14,400. So here itself, before you go for the next calculation, here itself you must understand that 14,000 is quite close to 14,400. So answer has to be approximately close to 120, slightly less than 120. You can mark the answer there, right? But if at all we follow the procedure, then how do we get the answer? Look at this. So let's take 110 as the base. 110 plus. Now because you've taken 110, you have to take the difference of 14,000 with 12,100. What's the difference of 14,000 and 12,100? 14,000 and 12,100. It is 1,900. Yes or no? 1,900. 1,900 divided by twice this value. Divided by 2 into 110. Divided by 2 into 110. Are you able to follow? Right? 110 plus. Why 110? Because 110 is 12,100, which for us is close to 14,000. So 110 plus the difference of 12,100, 14,000, 1,900 divided by 2 times this value, 2 times 110, right? So if at all you say zeros get cancelled, right? How much is this? 190 divided by 22. 190 divided by 22. Now try to calculate this approximately 190 by 22. How do you do? 190 by 22. 22 into 5 is 110. 22 into 10 is 220. 190 is how much less? 20 less. So approximately 9 times. 22 into 9 is how much? 22 into 9 will be 198. This is close to 198, right? So you can say approximately 19 times, approximately 9 times, right? Approximately 9 times. So 9 times, let's take 9 times. Or to be precise, you can say 8.5 times. I mean, if you really try to understand, this is not 9 times, less than that. So 8.5 or whatever it is. Approximately 9, let's say. So 110 plus 9, 119. So approximately 119 square. Now you can verify, find out what is 119 into 119. You will get very close to 14,000. So this is how you can find out the square root of a given number, right? Square root, approximate square root of a given number, right? If the given number is a perfect square, you know what the 3-step process. There will get the exact answer. And generally perfect squares are asked in case of simplifications, right? Remember friends, in simplifications, whenever a number is given to you, it should always be taken as, take it for granted. Just take it as a perfect square and apply the 3-step process to get the answer, which you have already discussed in speed maths. If at all the question is asked in approximations, there, most of the times an imperfect square is given. So for that, we need to apply this process and get the required answer. Right? So that's about finding out approximate square roots. Let's now move on to the next part, that is finding out approximate cube roots. How do you find out approximate cube roots? Right? Again, you know how to find out the exact cube root. For example, perfect cube is given to you, or a cube root is given under simplifications, right? Simple 2-step process. It should not take more than 3 seconds, right? Approximate exact cube root, 2-step process. The first step is find out the unit space. Second step is leave the last 3 digits, find out the highest cube less than the remaining part, and that will give you the tens list. So this process has been discussed in detail in the speed maths video. But now what we are going to look at is how to find out approximate cube root, right? Generally, if cube root is asked in case of approximations. So this again is a kind of technique that you need to remember, follow, and you will get the answer there. For example, let's start with 80,000. I have to find out approximate cube root of 80,000. What is the cube root of 80,000? The question says find out what comes in place of question mark. What comes in place of question mark? And then they also mentioned that you need not do the exact calculation. So which means approximate, right? So you have to find out the approximate cube root of 80,000. Cube root of 80,000. How do you do this? How do you find out the cube root? Now look at this. This again is a simple step-by-step process that you need to follow. Try to understand the range first. What will be the range? Like in case of square roots, you have understood that the answer may be between 40 and 50, or maybe between 60 and 70, right? So likewise, let's first understand what can be the range of the answer here, right? So if you start looking at cubes, 10 cube is 1000, 20 cube, 2 cube is 8, 20 cube 8000. What is 3 cube? 3 cube is 27. So 30 cube will be 27 followed by 3 zeros. So 27,000, right? What about 4 cube? 4 cube is 64,000. 5 cube will be 1,25,000. 125 followed by 3 zeros, right? So this is what we always remember, right? This is what is there with us. Now you need to understand this 80,000 falls between which of those two values. So can you say 80,000 is between 64,000 and 1,25,000? 64,000 is 40 cube. 1,25,000 is 50 cube, right? 40 cube is equal to 64,000. What about 50 cube? 50 cube is equal to 1,25,000. This value here, 80,000, is between 64,000 and 1,25,000. So the range of 80,000 falls between 64,000 and 1,25,000. So it's obvious that its cube root should be between 40 and 50. Look at the options. And believe me friends, most of the times there will be only one option which is between 40 and 50. You can blindly mark that as answer. You don't have to worry about the remaining options. You don't have to worry about the process there, right? But if at all the options given are little complicated, or two or more than two options are between 40 and 50, then how do you find out which is the correct answer, right? Believe me, most of the times only one option satisfies this range criteria and you'll be able to mark the answer. But if at all you have to go for the next step, right, then how do we get the required answer? So clearly we know that the answer should be between 40 and 50, right? The answer has to be between 40 and 50. So 40 plus something, right? 40 plus something. So let's take 40 plus how much is the question now? 40 plus how much? Look at this. Again, we will try to take some numerator by denominator. What is going to be the numerator? The numerator here will be the difference of 64,000 and 80,000. Like in the previous case, what we have done in case of approximate square roots, what's the difference between the given value and the square that we have taken, right? So likewise here, what's the difference between the given value and the cube of this number, right? So how much is that? 80,000 difference 64,000. 80,000 difference 64,000. How much is that? 16,000. This is equal to 16,000. So this will be 16,000 divided by what is the denominator? That's the question. Now don't take 2 times 40 or 3 times 40. Generally students try to apply their own method, right? For square roots we have taken 2 into 40. So they think maybe for cube roots we should take 3 into 40. No, that's not the idea, right? What should be the denominator here? What is the denominator? Understand. The denominator will be the difference of these two values. We very well know that 80,000 falls between 40 and 50. 40 cube and 50 cube, right? So take the difference of these two values in the denominator, right? So what is 64,000 difference 1,25,000? It will be equal to 61,000. So you can take 61,000. So this should go in the denominator, 61,000. Are you able to follow? So 40 is what is within that. 64,000 is 40. 40 cube is 64,000 plus the difference of the given value with 40 cube, 16,000 divided by how much? 61,000. What is the 61,000? The difference of 64,000 and 1,25,000. Again, here does not end the process. This should be multiplied with 10. Now try to understand what actually happens here. We know that from 40 cube, that is 64,000, you have to travel 16,000 kilometers. Let's say this is about time and distance, right? We are talking about some distance there. So from 64,000, which is 40 cube, you have to travel how many more kilometers? 16,000 kilometers to reach 80,000. So that's the distance divided by the actual distance between these two values, 64,000 and 1,25,000, 61,000 kilometers. Now this will give you a fraction. Fraction should be multiplied with 10 because that value will be in terms of tens. I mean, you should take in terms of tens there. Whatever fraction here, when multiplied by 10, will actually give you the extra part. So 40 plus that extra will give you the answer. Now try to simplify this 16,000 by 61,000. You can go for an approximate calculation. You need not do the exact calculation here. So zeros anyway get cancelled. Zeros anyway get cancelled here. 16 by 61. 16 by 61. Can I say this is 4 into 4 and 4 into 15? 4 into 4 is 16. 4 into 15 is 60. 60, approximately 61. Right? Or if you want to go for a precise one, you can say this 15.25. Right? 15.25. 4 into 15.25 is 61. So 4 by 15. Again 4 by 15, can you take it as 1 by 4 approximately? Yes, 4 by 15 is approximately 1 by 4. Or you know, strictly speaking, it will be more than 1 by 4 because actual denominator is less. When the actual denominator is less, actual value will be more, right? Anyway, approximately 1 by 4. 1 by 4 is 0.25. Yes or no? 1 by 4 is 0.25. 0.25 multiplied by 10, 2.5. So your answer here will be 40 plus 10 into 0.25, which is equal to 42.5. This is 2.5, 2.5 plus 40, 42.5. So 42.5 cube is approximately 80,000, or you can say 43. Generally, it is on the higher end, right? So 43 cube will be equal to 80,000. So that's the process that you need to stick to for finding out approximate cube roots. Are you able to follow, friends? Just look at the process once again. We are required to find out the cube root of 80,000. Obviously, 80,000 is not a perfect cube because a perfect cube will not have 4 zeros in it, right? It will have 3 zeros or 6 zeros or 9 zeros, multiples of 3. Anyway, approximations question, so we have to go for approximate calculation. Now, 80,000 is more than 64,000. Why are we talking about 64,000 here? Because 64,000 is 40 cube. So that 40 plus additional part, 80,000 is how much more than 64,000? It is 16,000 more. 16,000 divided by 61,000. Thus, this denominator here is important. What is the 61,000? 61,000 is the difference of these two values. So 16 by 61,000 approximately 1 by 4, 1/4 of 10, 2.5, right? 2.5 plus 40, 42.5. So approximately 43 is the answer. You can check in your calculators. Find out 43 cube. You will find it close to 80,000. So that is the logic that you need to follow. Let's take one more example of finding out approximate cube root, and then we'll move on to the next part. Let's say we have to find out the cube root of 2,50,000. Cube root of 2,50,000. What is the cube root of 2,50,000? How do you do this? Find out the cube root of 2,50,000. Believe me, friends, approximations is actually considered to be complicated, but then the kind of questions that you get in the exam are actually simple, right? You can very easily mark the answers here because options are not too complicated, right? If at all the given options are very complicated, you better leave the question, because if at all you have to find out the exact answer for approximations, it would definitely take more than 1 minute, right? So it doesn't make sense in spending so much time to get that 1 mark where the options are very close, right? Just look at the options first, right? The rule here is, the strategy here is first look at the options. First look at the options, understand, are the options given in such a way that I can go for approximation calculation? Yes, approximate calculation. If yes, go for it. If the options are too close, that going for an approximate calculation may not be able to, may not help you to mark the correct answer, then just leave that question. Happily leave that question and move to the next one, because there's no point in spending time on questions on approximations where the options are very close, right? Anyway, let's look at this. Finding out the cube root of 2,50,000. What's the cube root of 2,50,000? I think I'll give you 30 seconds because we have already learned how to find out the cube root. Your time starts now. Within 30 seconds, give me an approximate answer, right? You did not give me a precise answer. Just give me an integer like 42, 43, 44, whatever it is, right? Whatever the range might be. 30 seconds, your time starts now. All right, so I just hope all of you have got the right answer. Let's right answer is not the right answer, but approximate answer. Let's look at the solution. 2,50,000. Now, without writing all those steps here, you must be able to understand the range. 2,16,000 should be between 60 and 70 cube, because 60 cube is 2,16,000. 6 cube 216. So followed by 3 zeros. 2,16,000. 70 cube will be 3,43,000. So this is between 60 and 70. That's the range. Look at the options. If there's only one option, you have your answer there without writing anything on paper. If at all there are more than one options, right? There's more than one option which is falling between the range of 60 to 70, then you go for the next step. So what do you do? 2,16,000. 60 cube is 2 lakh. See, you don't have to write all these steps. I'm just writing it so that I can explain it to you, right? As such, when you do it in the exam, cut down the number of steps. So 60 cube, 2,16,000. What about 70 cube? 70 cube can be taken as, what is 70 cube? 3,43,000. Yes or no? 3,40,000. So 2,16,000, 7 cube 343. So 3,43,000. Now this 2,50,000 falls between these two. So I can say 60 plus 10 into something. Understand, it's always in the range of tens of that fraction. Now what fraction? What will be the numerator? The difference of 2,50,000 and 2,16,000. Yes or no? The difference of 2,50,000 and 2,16,000. How much is that? 34,000. 34,000, or directly take 34. Don't worry about those thousands, because 1,000 in the numerator and denominator anyway gets cancelled, right? So 250 minus 216 is how much? 34. Then the difference of these two values, 343 minus 216. Yes or no? 60 to 70. 343 minus 216. How much is this? 216 and 343. 60 cube is 2,16,000. 70 cube is like, I hope all of you are able to follow this part. Yes or no? 6 cube 216, 7 cube 343. Thousands, right? So the denominator will be the difference of 343 and 216. Yes or no? 343. You don't have to write this again. I'm just trying to write it here so that when you refer the video again, you will be able to understand what is the denominator, or how did we get the denominator? So the difference of 343 and 216. How much is that? 343 minus 200, 143. How do you do it quickly in a smart way? Don't subtract 216, subtract 200. Yes, 343 minus 200 is 143. But you know that you should subtract 16 more. So 143 minus 16. What is 143 minus 16? This will be 127. Yes or no? So we can say here the value is 127. That's it. Now try to do the calculation further. Are you able to follow? 343. This is 127. Get the point? 127. So 60 plus 10 into 34 by 127. Now do an approximate calculation. How do you do an approximate calculation there? Can I say this is 34 and 127? How do you cancel this? 34 into 4. What is 34 into 4? 34 into 4. 120 plus 16. 136. Close to 136, right? Or if at all you want to do a precise calculation, right? A little precise calculation. Try to do some other cancellation there, right? 17 2 times. This can be taken as 17 into 7 and 8 times. So 2 by 8, right? So anyway, it's going to be like around 1 by 4, right? So I can say this is 17 or 34 into 1. Let's say approximately 34 into 4. Again, the same idea. So 60 plus 10 into 1 by 4. You can say answer is approximately 62.5 or 63 for that matter, 63. So 63 cube will be close to 2,50,000, right? So this is how you go for finding out the cube roots of a given number which is not a perfect cube, or if the question is given in approximations. So let's now move on to the next part, that is how do you do the other approximate calculations. We'll take up questions from the workbook, don't worry about that. We'll try to take 5-6 examples there. But then how do you do approximations related to multiplications, which again is very, very important, right? Generally, divisions is not difficult. Approximations in divisions will not be really difficult, because even if you try to round off the given number, you will get a very close answer. But in multiplications, we generally find that the answer changes a lot, right? The actual answer and the approximate answer, there will be a huge difference if you do not do it properly. So let's take an example and understand how to do approximate multiplications. For example, let's say I have to multiply 24.3 should be multiplied with 36.3. What is 24.3 into 36.3? Approximate calculation again. You are required to do an approximate calculation. So what do you do? I mean, the first idea that we get here, is this is 24 into 36. Let's say approximately 24 into 36. 0.3 and 0.3 is neglected. So 24 into 36. What is 24 into 36? It will be 864. 30 plus 6, 30 minus 6, 30 square minus 6 square, 864, right? So you know that 24 into 36 is exactly equal to 864. So can I say approximately 24.3 into 36.3 is also 864? Based on the options again. If the options are close, you'll have to go for the precise calculation. If the options are not too close, then whichever is close to 864 can be taken as answer. Obviously, the answer should be more than 864. Why it has to be more than 864? Because the actual values are more. 24.3 is more than 24. 36.3 is more than 36. So when we multiply two larger values, obviously the product will also be larger. So answer has to be more than 864. So that's the first thought that you get. Look at the options. If there's only one option which is more than 864, mark that as answer. Again, more than 864 doesn't mean that it will go in 1500 or 2000. Close to 864, right? Now, if at all there are more than two options, or let's say if there is more than one option which is close to 864, and both of them are more than 864, then how do you decide which one is correct? So here, next what we need to understand is how much approximation have we done? Are you able to follow? How much far away are we from the exact answer? Try to understand. I'll split 24.3 and 36.3, and let's understand what actually happens here. For example, if I take 24.3, you know that 24 into 36 is 864. 24 into 36 is equal to 864. So just keep this in mind, and let's understand how much close or how much far are we from the exact answer, right? The exact answer is not known to us. We'll not even calculate the exact answer, but let's understand the process. So 24.3, if I take it as 24 plus 0.3 into 36.3, if I take it as 36 plus 0.3, what happens? A plus B into C plus D. So you know that each term must be multiplied. 24 must be multiplied with 36, 24 must be multiplied with 0.3, 0.3 must be multiplied with 36, and 0.3 must be multiplied with 0.3. So 24 into 36 is one step, plus 0.3 into 36 is the next part, plus 0.3 into 24 or 24 into 0.3 plus what is the fourth term? 0.3 into 0.3. Now look at this. What have we actually done? We have considered it to be approximately 864. So if there's only one option, you know the answer. But how do you get the answer when more than two options satisfy or more than one option satisfy 864 range there? 24 into 36 is 864. This anyway we know. We need to take care of the remaining terms. Again, when it comes to remaining terms, 0.3 into 0.3 doesn't really matter. I mean, what is 0.3 into 0.3? 0.09 or 0.1. Yes or no? 0.09, approximately 0.1 we can say. So this part can be neglected. This part can be neglected. But the remaining two terms cannot be neglected. For example, what is 0.3 into 36? Just think of this, 0.3 into 36. 3 into 36 is 108. So 0.3 into 36 will be 10.8. Plus, what is 24 into 0.3? 24 into 3 is 72. So 24 into 0.3 will be 7.2. Plus, again, if you look at this part as well, 0.3 into 0.3 will be 0.09. If you really understand, what we have initially considered is 864. That's the best way to do it, right? If at all more than one option goes in the range of 864, then consider these parts as well. 10.8 plus 7.2. How much is that? 18. Now try to understand. When you take 24.3 into 36.3 as 24 into 36 approximately, you don't get a difference of 1 or 2, right? Generally, we feel that maybe a difference of 1 or 2. No, that's not the idea. The difference here will be how much? Is around 18. Yes or no? 10.2 plus 7.2 is 18. That means the actual answer 24.3 into 36.3 should be 864 plus 18 plus this part 0.09. What is 864 plus 18? 882. 882 plus 0.09. 882.09. That's the exact value. But then we are not required to find this one. The question clearly says that you are not supposed to calculate the exact answer. We are supposed to do an approximate calculation. So this can be neglected. But then based on the options, you cannot avoid this part. And again, let me tell you, when you actually do the calculation here, you don't have to write the step-by-step process. It's just understand 24 into 36, 864, 0.3 into 36, 0.3 into 24. Right? Or here again, if you take 0.3 common, I can say 24 plus 36 is 60. 0.3 into 60 is 18. But always it may not be possible. For example, if it is 24.3 into 36.8, let's say, then again what do? 4 terms you will get. Here 0.3 can be taken common. If some of you have got the idea of taking 0.3 common, good, well and good. But that's not possible always. So this is something which you need to keep in mind. What is that? You do an approximate calculation. I don't say that 864 is wrong. 864 is approximately correct. But again, here the answer depends on the type of options given to us. Are you able to follow? Generally, if the question is on simplifications, there is a fixed answer. Only when you get that, you will get the right answer. You will get that 1 mark. But approximations, it depends on how much of approximation has been done, and that is only based on the given options. Right? So remember, while solving these questions from approximations, always you have to take care of the options there. Look at the options. Understand, right? To what extent you can go for approximation. If the options are too close, maybe you leave the question if you find it really very close. If they are not so close, then try to first go for 864. Then see if 864 is giving you the right idea or not. If not, just check 0.3 into 36, 0.3 into 24. Likewise for 3-digit numbers, 4-digit numbers, same idea. Just try to go for an approximate way of getting the answer. Again, based on the options. Let me tell you why I have taken multiplications here, because divisions generally doesn't matter. Divisions, when you do this approximation, suppose 0.3 is neglected in the numerator and 0.3 is neglected in the denominator, you don't get much of a difference. But multiplication, you get a lot of difference, right? So that is the reason we have taken multiplications as the case here, as the example. Again, while solving the questions, we look at divisions as well, additions and subtractions, right? So just keep this in mind. The other point which I would like to tell here is, though this may not be really useful, but remember, whenever you are doing multiplications, never increase both the values or never decrease both the values. Now you may tell here that you only have decreased both the values. Yes, 24.3 we have taken 24, 36.3 we have taken 36, but then ideally you should not decrease both the values. You will get an answer which is far away from the exact answer, or you should not increase both the values. Increase one, decrease the other in multiplications, right? Are you able to follow? For example, when I decrease 24.3 and increase 36.3, what happens? This reduction will reduce the answer. This increment will increase the answer. So it's balanced. One is decreasing, the other is increasing. So somehow it gets balanced. If I decrease both of them, what happens? Because 24.3 has become 24, our answer will get reduced. 36.3 becomes 36, our answer gets further reduced. So you are moving far away from the exact answer, right? But generally this doesn't happen. I mean, we don't have to really worry about this, but just keep this in mind. Multiplications, it's ideally suggested that you increase one, decrease the other. If you decrease the first one, increase the other one. And that this happens only when you're changing both of them. If at all you're changing only one of them, then doesn't matter. But when you change both the values, just try to follow this, right? But then more than that, what is important is you must be able to understand how far are you from the exact answer. 864 plus somewhere around 20. So 884 you can say, 882 you can say, and mark the given options. But when it comes to divisions, as I mentioned, generally it doesn't matter. There's not much of a difference. But remember, in divisions, either increase both numerator and denominator or decrease both numerator and denominator. If at all you change both of them, if at all you want to change both the values, both numerator as well as denominator, do a similar change. Increase both or decrease both. Never increase the numerator and decrease the denominator, or decrease the numerator and increase the denominator, because this will give you extreme answers. You have to be in the mean range, right? Close to the exact answer. So when you increase both, you'll remain close to the exact answer. When you decrease both, you'll remain close to the exact answer. But when you do opposite changes in numerator and denominator, either you will fall on that side, higher side, or the lower side. So just try to understand this. I mean, you may not necessarily apply this always. I mean, you don't have to worry about this too much in the exam, but then just keep this in mind, right? That's something which you need to understand. Same thing happens for additions and subtractions, right? For example, when you're adding two numbers, let's say 18 and I have to add 18 and 29, right? I mean, this approximate calculation is not required. You can anyway get the exact answer, but I'm just giving an idea. What do? Don't increase both the values, or don't decrease both the values. That's a wrong approximation. Increase one, decrease the other, or decrease one, increase the other. If at all, again, you want to change both of them. Because when you increase both of the values, both the ways you are going away from the answer. When you decrease both the values, you are moving away from the answer. Increase one, you move away, move up. Decrease the second one, you come down. So that's how you try to balance, right? So additions and multiplications always do opposite changes. Subtractions and divisions always do same changes, similar changes, both increase or both decrease, right? So just try to understand, just keep this in mind. Let's now take some examples, right? So this is important. How much away are you moving from the exact answer? I think I'll take one more example here of multiplication, because this actually gives a lot of difference. More than additions, subtractions, or divisions, right? For example, I have to multiply 3-digit numbers, let's say 362.8 into, you have to multiply 480.6 equals to what? Or let's say 484.6. We'll not do the exact calculation. Approximately, you know, 362 into 484, check the options. If there's only one option in that range, you can mark the answer. But what you need to understand is, understand that how much far or how much difference will you get when you check with the exact answer, and that only depends on these decimal parts. Simply don't neglect them. Don't neglect 0.8 and don't neglect 0.6 here, right? Understand how much far away will you move. 0.8 into 0.6, you don't have to worry. As I've mentioned in the previous case, the last part generally doesn't matter. What matters is the second and the third part. 0.8, see, 362 into 484 is the first step, so that anyway you will do. But 0.8 into 484, how much will that be? Try to understand. Will the difference be in tens? Will the difference be in 10, 20, 30, 40? Will the difference really be 10, 20? I mean, the difference of exact answer and approximate answer. No, the difference will go in hundreds. Look at this. 0.8 into 484. How much is that? 0.8 into 484. 484 into 1 is 484. 484 into 0.8 will be approximately 400. Yes or no? 484 into 0.8 into 0.8. How much is this? 484 minus 96, I should say, or 96.8, I should say. So approximately, I can say this will be around 487. 487. Are you able to follow? Sorry, not 487. 387. 484 into 0.8, 387. That means just because you neglect 0.8, you will get a difference of 387 in the answers. This is important. These things you must understand, and only then you'll be able to mark the right answers. Likewise, if you take 0.6 into 362, 362 into 0.6, how much is the difference? 0.6 or let's say 0.5. Half of 362 is how much? 181. More than 181. 181 plus 36, I can say, if you multiply with 0.6, right? So it will be around how much? 180 plus 36, 216, 217, approximately 270. So look at this. Just because we neglect 0.8 and 0.6, we are getting a difference of how much? 600. 600 is the difference. Yes or no? Isn't that surprising? So understand, neglect, 0.8, 0.6 neglect, but depends on options again, right? You must be able to do this approximate calculation quickly. That answer will be actually 600 more than what you get when you multiply 362 and 480. and then add that 600 and check. You don't have to worry about 0.8 into 0.6. What is 0.8 into 0.6? 0.48. 0.48 is 0.5, half. That doesn't really matter. What matters is this difference here. So this kind of calculation you must practice. And believe me, approximations is more to do with simplifications. If you are strong in simplifications, you will automatically get strong in approximations. And simplifications again depends on your speed maths. How quickly do you multiply? How quickly do you add, subtract, or divide? So it's all based on practice, practice, and more practice. So remember, make sure that you spend at least 30 minutes per day on your calculations, so that by the time you come for your SBI clerks exam, you really improve a lot when it comes to your calculations. Basic calculations, 2-digit multiplications, additions, subtractions, divisions, etc. Because if you get strong in that, your simplification will improve. And if your simplification improves, your approximations also improve. Right? This is a kind of art, I would say. Approximation is an art. Right? Approximate answer, what you get is correct, what I also get is correct. Both the answers may be different. Right? Your answer and my answer may be different. But then both are approximately correct. What matters is who has come closer. Who has come closer to the exact answer. Right? And that only depends on how good you are in calculations, how good you are in simplifications. So let's get started and let's look at some questions from approximations now. So let's take the first example from approximations, right? I'll just put the question on the board with all the 5 options, and you're required to do the approximate calculation. Let's see how many of you get the right answers here. So let's start with this one. So these are the options, right? The question here says 1504 into 5.856 minus 24.091 is equal to what? Options are 7,200, 9,500, 6,950, 5,480 and 8,800. Now, you know that while doing any kind of simplification, you have to stick to the bottom-up principle, right? First divisions, then multiplications, additions and subtractions when it comes to the basic arithmetic calculation. So here we'll always have to go for multiplication first and then subtract this value to get the required answer. But as I've mentioned in the beginning of the session, before you actually look at the question, you're supposed to throw a glance at the options and get an idea of what kind of approximation can you do. I mean, to what extent can you go for an approximate calculation? Look at the options: 7,200, 9,500, 6,950, 5,400, 8,800. I mean, options are not too close to each other, right? So try to do a very approximate calculation, right? You need not be sticking to very precise calculations, right? So look at this. 1504 is approximately 1500 and 5.856. Can I approximately take it as 6? Yes or no? Again, understand, we are decreasing one value, increasing the other value. I mean, try to maintain this as much as possible. So I'll take this as 1500. Don't take this as 5. You'll be moving far from the exact answer, right? Take it as 6, right? Take it as 6. So 1500 into 6 minus 24.091 is what? 24. And I don't think this is any bit difficult, right? 1500 into 6. What is 1500 into 6? 9,000. 1500 into 6 is 9,000. 9,000 minus 24. 8,976. Look at the options. Do you find 7,200 close? No. Do you find 9,500 close? No. What is our approximate answer? It is 8,976. 9,000 minus 24. So cannot be the answer. Killed. Cannot be the answer. Kill it. 6,950. No way close. No way close. We are left with 8,800. That's the answer. And maybe the exact answer will be close to 8,000. Now don't again worry about why the answer is differing by 200, approximately 200, right? 8,976 and 8,800 is what? 176 is the difference. You know why? We have already learned this because we have taken it as 6. How much more? 0.144 more. But that 0.144 is being multiplied by 150. Are you able to follow? So approximately 0.144, 0.15 times of 1500 will be close to 200 to 25, right? So the point here is we are not trying to find out what is the right answer. We are trying to find out what cannot be the answers. 7,200 is not the answer. 9,500 is not the answer. 6,950, 5,480 are not the answers. Hence, fifth option 8,800 can be taken as a correct answer. For the same question, if the options are given as 8800, 8801, 8802.76, 8802.85, it becomes difficult, right? Then you have to decide, can you really be able to mark the correct answer even if you try to do it on paper? Right? If you feel yes, go for the calculation. Otherwise, just leave it, because approximations, if the options are too close, you generally have to avoid those kind of questions there, right? So that's how you can go for approximate calculations. Now, you may also be wondering that maybe intentionally we have given the options in this way so that 4 of them get eliminated. What if in the exam it doesn't get eliminated? Believe me, this question is one of the previous SBI clerks exam question. In fact, all the questions that we have in the workbook there are all previous year's SBI clerks exams, so that you actually get a feel of what kind of questions have been asked. Now, tomorrow in the exam they may increase the difficulty level. That's a different story. But then what have been asked so far can actually be done very easily without having to put too much of effort there, right? Let's take the next question. I mean, this is really simple. I don't have to explain too much here, but let's quickly look at this. 24.7582 plus 5.015 equals to what? Let's not use options, right? Options are anyway there. You can just look at them. But let's understand. 16.928 is what? 17, approximately 17. 24.75 is approximately 25. 17 and 25, 42. 42 and 5, 47. Answer should be close to 47. Look at the options. In fact, you are required to look at the options before, right? I mean, I did not give the answers because anyway, you can directly mark the answer by an approximate calculation. But when you do it in the exam, remember, look at the options. So 47, we are getting close to 47. Options are 35, 40, 22, 12, 45. Obvious. Fifth option, 45 is the answer, right? Look at this one. Cube root of 7.938 multiplied with 6.120 whole squared minus 4.9256 equals to what? The options are 70, 55, 30, 25 and 90. Now cube root of 7.938, cube root of 7.938. What will be the value here? Cube root of 7.938. Can I take it as approximately 8? What is the cube root of 8? Cube root of 8 is 2. So this part here is 2, approximately 2. What about 6.120 whole square? 6 square, right? 6 square, 6.12, 6.12, approximately 6. 6 square is what? 36. Now 2 into 36 minus 4.9256 can be taken as 5. What is the answer here? 2 into 36, 72. 72 minus 5, 67. Getting the point? 2 into 36, 72. 72 minus 5, 67. Are we close to 67 here? Which option? Which option? 70. First option 70 can be taken as the required answer. Yes, because anyway 7.938 will be very close to 2, slightly less than 2, but 6.12 square will be more than 36. That you need to keep in mind, right? Let's say here if we have got approximately 67, but let's say there's one more option. One option is 70, the other option is 65. In that case, what do you do? 70 is close to 67, 65 is also close to 67. Anyway, 30, 25, 90 are ruled out. But these two are possible. 70 is possible, 65 is also possible. And approximately our calculation says it's 67. So what do you do? 2 into 36, 72 minus 5, 67. Which one is the correct answer? In such a situation, you have to analyze. Will the actual answer be more or less? How do you do that? 7.938, no doubt it's going to be very close to 2 because cube root, that doesn't really give you a huge difference. But what gives you a difference here is 6.12. We have taken 6 square, but actually it is 6.12. 6.12 square will be more than 36. 36 when 2 when multiplied by more than 36, this will be more than 72. More than 72 minus 5. In fact, less than 5. Answer has to be more than 67. Every step tells that answer has to be more than 67. So that is the reason first option 70 can be taken as a right answer. So that's the approach that you need to follow when two options seems to be close. First decide which is, is the correct answer will be more or less, right? Otherwise, if that situation arises, try to decide this. So otherwise you can directly mark the answer based on which option is close to the given. Which answer option is close to the answer that we have got, right? Let's now look at the next one. Quickly, the next one. 16.046 divided by 2.8 into 0.599 is equal to what? The options are 3.5, 7.9, 1.9, 5.6, 6.2. What do? First division, then you have to go for multiplication, or from left to right you can just proceed, right? That doesn't really matter when there are only multiplications and divisions. Remember, Bodmer's rule says when there are only multiplications and divisions, you can simply proceed from left to right, or do divisions first, then go for multiplications. So anyway, let's look at this. 16.046. This is approximately 16 divided by 2.83 into 0.599. It is taken as 0.6. Get the point? Options are very far away. 3.5, 7.9, 1.9, 5.6, 6.2, nowhere close to each other. So I can definitely go for that kind of calculation and get the answer. So 16 by 3 will be how much? 15 by 3 is 5. 16 by 3 will be 5.33. Yes or no? 16 by 3 is 5.33. 5.33 into 0.6. 5 into 0.6. 5 into 0.6. 5 into 0.6 how much? 3. 5 into 0.6 is 3. 5.33 into 0.6 will be more than 3, slightly more than 3. Look at the options. First option 3.5 has to be the answer. So really very easy. It's not complicated, right? These are all previous years SBI clerks questions. So this is how we can solve them. But I don't say that every question will be this simple. You will get complicated ones as well, where doing such an approximation may not be able to give the answer. So then you have to go for a further precise calculation, or just leave it, right? It all depends on what kind of options are given. We'll look at one or two questions of those type as well. Let's quickly look at the next one here. Square root of 963 plus 4.895 whole squared minus 9.24 equals to what? The options are 60, 35, 85, 45 and 25. What will be the answer? What's the square root of 963? Square root of 963. Square root of 900 is 30. Square root of 961 is 31. Yes or no? 31 square is 961. So very close to 31. Yes or no? 961 is 31. 963 can be taken as close to 31. 4.895. Can I take it as 5 approximately? 5 square, 25. Minus 9.24. Let's take it as 9 or 9.5, whatever it is. 9.24, let's say otherwise. So 31 plus 25 minus 9.24. Find out what is 31 plus 25? 56. 56 minus 9.24. 46, right? 46 point something. Which is the closest one? Fourth option, 45. So the answer here should be fourth option, 45. So this is one set of questions that we've taken, right? Really simple, not complicated. Just try to do an approximate calculation and you'll get the right answer. So follow Bodmer's rule, right? You don't have to neglect that. Follow that rule and you'll be getting the right answers there. Now let's look at some typical ones. For example, 6.1 into 24.879 plus 14.059 minus 6 equals to what? The given options are 110, 190, 220, 160 and 98, right? So 110, 190, 220, 160 and 98, right? I think I'll give you a chance this time. 30 seconds, you should be able to get the right answer. In fact, 30 seconds also is too much, but then let's take some time. 30 seconds, your time starts now. All right, I think most of you are getting the answers. There's one confusion. I think it's from Ankit. He says 1504 into 5.856 minus 24.091 equals to what? Now he says 1504 into 5.856 can be taken as 6. So 1504 into 6 will be 9024. 9024 minus 24 is 9000. So now the question that he raises there is, like, should I go for 8800 or 9500? First of all, very clearly 9000 is close to 8800 and far away from 9500 if you really compare these two values, right? So you have to go for 8800. And moreover, if you try to analyze that whether the answer is going to be more than 9000 or less than 9000, which already I've explained in one other question there, you'll get a clear idea that the answer is going to be 8800, right? So you don't have to worry about something which I've not explained there, right? It's all about your analysis. If I solve this question for you, maybe you will get the answer, but you should be able to analyze by yourself. For example, 1504, you have taken it as, 1504 is as it is, you have taken 5.856 as 6. You have increased the value, right? And because of that increase, your overall value will increase. Minus 24 you have taken as it is. That means what? Because 1504 into 6 is much more than 1504 into 5.856, your answer is going to be, your approximate answer is more. Actual answer should be less. Are you able to follow? The actual value is less, 5.856. So that is the reason actual product will be less. And the actual product is less, actual answer will be also less. Will be less than 9000 what you have got. So less than 9000 here is 8800. So this is how you can just analyze whether it is more or less and accordingly mark the answer. I think it's time to look at this one now. 6.1 into 24.879 plus 14.059 minus 6 equals to what? What do you do? 24.879, shall we take it as 25 approximately? Yes. Can I take this as 6? Yes. 6 into 25 plus 14.059 is very close to 14 minus 6. Right? This is within the brackets. As per the rules, first simplify the bracketed part. So this becomes 8. 14 minus 6 is 8. Now 6 into 25 plus 8. What is 6 into 25? 150. 150 plus 8. 158 should be the answer. Approximately 158. Look at the options. 110 is ruled out. 190 is ruled out. 220 is ruled out. 98 is ruled out. 160. Close to 158. And here we don't have to worry about two options being close. There's only one option, so directly you can mark that as the answer. Right? Let's now look at the next one. So the question here is 3451 divided by 9.895 multiplied with 3.0126 equals to what? 1050, 1235, 990, 1360 and 1248. I think 30 seconds should be sufficient. Your time starts now. Alright, so let's look at the solution now. 3451 divided by 9.895 into 3.0126. 1050, 1235, 900, 1360, 1248 are all not close to each other. So this becomes 3 approximately 3451. Let's keep it as 3451, right? 9.895. Can I take it as 10? Yes, nothing wrong. I mean 9.895 and 10, there's hardly any difference, right? 0.15 is the difference, right? So 3451 divided by 10. 3451 divided by 10 is how much? 345. 345.1, right? So 345 into 3. What is 345 into 3? 340 into 3. 340 into 3, 1020. 5 into 3, 1035. So answer should be close to 1035. Right? This cannot be the answer. 1360 cannot be the answer. 990 maybe. 1235 cannot be the answer. Right? So again, if you look at it, 1035, 990 is close. 45. And how much is this? Just 15. But then now you have to really understand, will the answer be more than 1035 or less than 1035? If it is coming out to be more than 1035, that's the answer. If it is anyway less than 1035, then this will be the answer. Now look at this. We did not change this value. 3451 was 3451 as it is. Yes or no? 3451 was as it is taken as 3451. But then 9.895. Now try to understand. 3451 divided by 9.895. This was approximately taken as 10. Look at this. When we approximately take it as 10, we have got the answer as 345.1 or 345 approximately, right? But the actual denominator is less. Approximate denominator is 10. Actual denominator is less. What happens when the denominator is less? Value will be more. Yes or no? This is very classical mathematics. When the denominator is less, value will be more. Actual denominator is less. That means actual value will be more. When the actual denominator is less, actual value will be more. That means actual answer should be more than 345. Approximately 345 because approximate denominator is 10. But the actual denominator is less than 10. When the actual denominator is less, actual value will be more than 345. This is more than 345. When something more than 345 is multiplied with 3, obviously answer will also be more than 1035. So this 990 gets ruled out. Now I can say 1050 is the correct answer. So that's how we can verify which is correct, the first one or the second one. I mean, it should be more or less. So just take I think cube root of 80,000. We have already done this. Answer should be close to 43 there. Then what about this one? 5995 plus 4874 plus 3333 divided by 713 plus 509 plus 326 equals to what? The options are 11, 9, 11.5, 7.5 and 12. So 5995 plus 4874 plus 3333 divided by 713 plus 509 plus 326. Now 11, 9, 11.5, 7.5, 12 are actually close. So what do we do? Should we leave it? Because see, if at all you get the answer to be between 11, I mean close to 11, then there's a dilemma. Is it 11 or 11.5? Or if you find the answer to be 10, then is it 9 or 11? You know, 7.5 again is okay, but then 11, 11.5, 12. So seems like answer will be very close. Answer will be, I mean, given options are close. But then let's give it a try. I mean, you either can leave it, that's the best option. I mean, that's one of the options. Or otherwise, just give it a try and see if really we are getting the answer close to 11 or not. If at all the answer is close to 6, 7, I can mark this. If it is going to be more than 11, I can mark this. Or anything other than that, I can go for 9. So it depends on how the calculation will be done, right? And understand, try to do a close calculation. I mean, don't do a real approximation here because options are anyway close. So 5,995, or I think I'll give you some time, try it out. 30 seconds, try this one. Do not write anything on paper. Without putting pen on paper, you must be able to understand, understand what? That can you be able to do this or not, right? It's like data sufficiency. First you decide, is it, I mean, not data sufficiency exactly, but then you decide, is it worth solving it or not, right? And then actually do the solution or just move to the next one. 30 seconds, your time starts now. All right, so let's look at the solution now for this question. So as I've mentioned, we are only trying to check if we'll be able to mark the answer or not. Otherwise, you have to leave it, right? So can I take this as 6,000, close to 6,000? 6,000 4,800 or 4,900, let's say 4,000. And see, remember, when you're just taking these values, the one thing that you need to keep in mind is, are you taking more values or lesser values? So that when you add the other value, you will accordingly do a change. As I've mentioned, not increase all the values in addition. Increase one, decrease the other, right? Similarly in division, increase both or decrease both. Multiplication, do opposite changes. Subtraction, do similar changes. So the point here is 5,995 taken 6,000, close to 6,000. But the one point which you need to keep in mind is it's 5 more. So you have increase the value. Likewise, 4,874 we have taken as 4,900. So 26 more, right? So just keep in mind that you are increasing. Now 3,333. Either you can take it as 3,350 or 3,400 if at all you want to go for that. But then understand, already we have increased the previous two values. So it's better that you decrease this one. So 3,333, if you decrease, can we take it as 3,300? Yes. So this is 3,300 divided by, now a similar case here, 713 and 5, and if you want, you can do the actual addition also. I mean, that's not really difficult. 713 plus 5 not only be 509 will be how much? 1222. 1222 plus 326 will be how much? 1548. So the exact calculation is 1548, right? If at all you're not, you're really good in calculation. So 700, 500, 300. How much is that? 1500. 13 and 9, 22. 20 and 22, 26 is 48. So if you're able to do the proper calculation, better go for it. So this will be how much? 1548. So divide by 1548 equals to what? Now this is the question, right? Now add this one, 6,000 and 4,900. How much is that? 10,900. 10,900 plus 3,300 will be 14,200. Yes or no? 14,200. So 14,200 divided by 1548. 14,200 divided by 1548. Now we are not far away from the exact answer because we have not done too much of approximation. Just 5 more and 26 more. How much? 31 more and 33 reduced. So very close. Are you able to follow? Actual numerator will be 14,202. We have taken 14,200, right? Very close. And this is exact 1548. Now the moment you see this 14,200 divided by 1548, you will know that first option, third option and fifth option cannot be the answers. Tell me why. 14,200 divided by 1420. Just try to understand. 14,200 divided by 1420. If the denominator is 1420, it will be equal to 10. 14,200 divided by 1420 will be equal to 10. Actual denominator is more. When the denominator is more, value will be less. That means answer should be less than 10. Get the point? If you only look at take the 4 digits, 1420 by 1548. 1420 by 1548. Answer should be less than 1. That means less than 10 when you multiply with 10 there, right? Less than 10. Answer should be less than 10. So 11, 11.5 and 12 gets cancelled. Are you able to follow? If it is 14,200 divided by 1420, I'll get exactly 10. So I'm just trying to compare with this part, this calculation. 14,200 divided by 1420 equals to 10. Here the actual numerator is more. When the actual numerator is more, actual value will be less than 10. Ruled out. Now either 9 or 7.5. At least you are able to cancel out 3 wrong options. Now if you want to take a risk, mark anywhere on the 9 or 7.5 or just try to understand. Can it be 7.5? No, we don't think so, right? Can it be 7.5? No, it should be 9. Approximate answer here should be 9. Let me tell you why. Only consider this part, 1420 divided by 1548. Let's take it as into 10. So whatever is this should be multiplied by 10. And if you have understood percentage based calculations, right? Look at this, 1420 by 1548. Find out approximately how much percentage is it. What percentage is 1420 by 1548? Generally we have into 100. Here we have into 10. That's the difference, right? So understand what is the percentage. What do we do in percentage related calculations? We have learned this in speed maths and percentages video as well, right? What do? Always take the denominator as 100%. So what's the denominator here? 1548, 1550. 100% is 1550. What will be 10%? 155. If you really look at the numerator 1420, it's how much? 1550 minus 130 less. Yes or no? 1550 minus 130 will give you 1420. So it's minus 130. That means 1550 minus 130 approximately. 1550 minus 130. This is approximately 1550. And this can be taken as 1550 minus 130. So if you understand, this is how much? 100%. Because denominator is always 100%. So this is 100% minus approximately, can you say this is 10%? 155 is 10%. This is less than 155. So less than 10%. So 100% minus 10%, 90%. 90% is what? 0.9. 0.9 into 10 will give you 9. So your answer here is 9. It cannot be 7.5. So this is how you can do such calculations. This is how you can go for approximation when it comes to this kind of a division. Again, it may not be possible always to mark the answer. Had the answer been close to 11, we would have been in trouble. Yes or no? We are fortunate that 11, 11.5 and 12 have got cancelled. If the answer is close to 11, then it becomes difficult. It can be 11, it may be 11.5, it may be 12 also. Right? So it all depends on what options are given to you. Right? I would say if at all you find the answer is close to 11, better leave it. Don't take a chance because 3 are possible. The only way to do it is do the complete calculation. I mean, try to do a very precise calculation in that case, or try to do it on paper. Maybe then you'll be able to find out the exact answer, right? And then, which one shall we take? %of 5647 plus 27% of 4589 equals to what? 6846, 6265, 6025, 5955, 5825. 89% of 5647 plus 27% of 4589 equals to what? 6846, 6265, 6025, 5955 and 5825. So percentage related calculation, again it's more or less based on simplifications. How strong are you in simplifications? If you're strong in simplifications, I believe you'll be able to mark the right answer, right? Otherwise it may be difficult. But then look at the options, not really close. 6800, 6200, 6000. Okay, these are close, and this again is not really close, right? So try to do an approximate calculation and see what answer seems to be correct, right? We'll meet after 30 seconds. I'll give you 30 seconds or 45 seconds because it's actually a kind of percentage based calculation and not really appearing to be good one. I mean, easy one there, right? 45 seconds, your time starts now. All right, so let's look at the solution for this one. Now, approximate calculation, we are required to do an approximate calculation. Clearly it says you're not supposed to get the exact answer. So try to do an approximation. I would say rather than changing the percentages, let's change the values here. Instead of approximating the percentages, let's approximate the values. So 5647, is it close to 5650? Very close to 5650. So we are taking it as 5650 plus, so as it is 89% of 5650 plus 27% of, what about this one, 4589, close to 4600, 4600. And remember, we have increased both. This has been increased minimum just by 3, right? The difference is 3. This has been increased by 11, right? But again, we are taking 89% of that 3. That is going to be the difference, and only 27% of that 11. So minimum difference is going to come in the answer that we obtained and the exact answer there, right? So we don't have to worry about answers being close. I think if you do this part clearly now, properly, you'll be able to mark the answer. Now look at this, 89% of 5650. It all depends on how do you do this calculation and how do you do this calculation. I don't think we need to do any approximate calculation there. You can do the exact calculation. What do you do? 89% of 5650. 89% is what? 100% minus 10% minus 1%. Yes or no? 89% is equal to 100. I am writing this, but as such, it is not required to be written on paper. It's all your understanding there, right? So 100% is how much? 5,650. This should be visualized. I mean, I'm writing so that I can explain you, but try to visualize. So 5,650 minus 10% of 5,650, 565 minus 1% of 5,650, 56.5. So what will this be? 5,650 minus 565 minus 56.5. 565 and 56.5. How much is that? Around 620, 620. So I can say this is going to be around 5,000. Yes or no? Close to 5,000. Close to 5,000. Are you able to follow? Slightly more than 5,000 in fact. 5,650 minus 565 minus 56.5. 565 and 56.5. How much is that? 565 and 56.5. It's going to be 620, close to 620 or 620, 620.5, 621.5, right? So 620, 5,650 minus 620 will be 5,000, or I can say 5,030, let's say. I mean, if you want to go for a precise calculation, right? 5,030. So that's the first part, 5,030. Plus what? 27% of 4,600. What is 27%? If you ask me, 27% is 20% plus 5% plus 2%. Keep it simple. Yes or no? 20% plus 5% plus 2%, or 30% minus 3%, or 25% plus 2%. Anyway, whatever is comfortable for you. 20%, 10% is 460, 20% will be double. 460 into 2. How much is that? 920 plus 5%. 10% is 460, 5% will be 230 plus 2%. 1% is 46, 2% will be 92. Values 920 and 230. How much will that be? 1150. 1150 plus 92. Can you take it as 1240? Approximately. In fact, 1242, 1240. So this part is 1240. Now add 5,030 plus 1240. So 6,040 plus 30, 6,070, close to 6,000. Sorry, 5,000 plus 1240 will be 6,240. 6,240 plus 30, 6,270. 6,270. Approximately 6,270. Which is the best option? This is far away. This is close. This doesn't seem to be close, because understand, we haven't moved really far away from the exact answer. That's what I was trying to tell you, right? We have just increased by 3, and when you take the actual difference, net difference, it is not actual 3, it is 89% of 3, which will be around 2.7 or less than that. Again, here also, we have not increased by 11, we have increased by 27% of 11. Are you able to follow? That is going to be the net difference. And here again, we have done almost very precise calculation. So we are very close to the exact answer. So I can say 6265 seems to be correct. Though, I mean, this anyway is ruled out, not close to 6270. 5955 also can be ruled out, right? So the correct answer here has to be 6265. And you also know that answer should be slightly less than this, because values were increased. Actual answer will be less. Slightly less than that. 6265 seems to be correct in all the ways there, right? So second option, 6265. So it's all practice, I would say, right? Approximations is more to do with practice. The more you practice, the easier it becomes, right? So that's how you can solve questions related to approximations. Is there anything else which I can do? Look at this one. Square root of 727.995 plus 5.1961 squared equals to question mark divided by 2 divided by 10.7960. 53, 44, 5, 15, 10. I mean, you should be really happy looking at such questions, because options, you look at the options, 53, 44, 5, 15, 10, all are, really far away. Let's try to do the calculation. 727.9995, 728, approximately 729, right? Approximately 729. What is square root of 729? Square root of 729, it's going to be 27. So this part is 27 plus 5.1961 square, approximately 5 square, 25, equals to some question mark divided by 2 by, let's take this as 10. 2 by 10 is how much? 1 by 5. 1 by 5 divided by 1 by 5. Now 27 plus 25 is how much? 52. 52 is equal to some question mark divided by 1 by 5. You know that When you take this part to the other side, it becomes into 1 by 5. Yes or no? Division when goes on the other side becomes into 1 by 5. So the question mark will be equal to 52 into 1 by 5. Approximately 10. Yes or no? Or 10.4. Which option? No way close, no way close, no way close, no way close. 10 has to be an answer. Fifth option, 10. There's nothing difficult here. The only thing which you have to be careful here, careful about here is that, in a hurry, maybe you take 52 into 5, right? 52 into 5, 250, which is not there in the options anyway. But if at all 250 is given, you may mark 250 as answer. Understand? Generally that's what we do, right? Take it to the other side. So 1 by 5 becomes into 5. But then division of 1 by 5, taking to the other side becomes into 1 by 5, right? And then approximately 10. 52 by 5 is 10, right? So the answer for this question has to be option 5, 10. Options 21, 8, 25, 13 and 13. If you remember guys, in the simplification session we have learned how to do fractions related calculations, how to do simplifications which are related to fractions. What do we do? If it is an addition subtraction based question, split the integer part and the fraction part, right? Otherwise, if it is multiplication related, try to reciprocate the second fraction and apply that to get the answer. Just multiply that to get the answer. Now here in approximations, what do we do? I would say only look at the integer part first, right? Here I don't have to explain, I would believe, but then just look at the integer parts. Don't worry about the fractions. So 1 plus 7 plus 3. How much is 1 plus 7? 8. 8 plus 3, 11. 8 plus 3 is 11. More than 11, right? There are some fractions to be added. 4 by 7, 1 by 3, 3 by 5. So more than 11. 8, 30, 21, 25 are not close. More than 11 does not mean that it can become 21, 25 or 30. These are all fractions. 3 by 5 is how much? 0.6. 1 by 3 is 0.33. So 0.6 and 0.33 is 0.93, approximately 1. And 4 by 7 again is 0.5. So 1.5. 11 plus 1.5, somewhere close to 12.5. So 13 seems to be the appropriate answer. So 13 is the correct answer, right? So this is how you can just go for fractions and simplify it. Look at this. 1 plus 7. 8, 8 plus 3, 11, more than 11, right? 13 directly you can mark. If it is negative, 1 plus 7, 8, 8 minus 3, minus, you have to be careful about that, minus 3 is 5, and whichever is close to that can be taken as answer, fine? All right, one last one here. Again, based on percentages, 0.8% of 384 into 0.9% of 362 equals to what? 0.8% of 384 into 0.9% of 362 equals to what? Let me also give you the options. 7, 8, 10, 12 and 15. 0.8% of 384 into 0.9% of 362. So that's like percentages you have to find out approximately and multiply them. What is 0.8% of 384? 0.8% is how much? I am not going to write anything on paper this time, right? It's all oral calculation, mental calculation. You must be able to do this, and it's all based on simplifications, right? Nothing really to do with much to do with approximations. 1% of 384 is 3.84. 3.84. 1% is 3.84. 0.8% is 1% minus 0.2%. 0.1% of 384 will be 0.384. So 0.2% will be double of that, right? 0.76. 0.76. So 0.8%, that is 1% minus 0.2%. So 3.84 minus 0.76, approximately 3.08. This is close to 3.08. Please do not misunderstand that I have memorized the answer. I'm just trying to speak it out. No, I'm trying to do the approximate calculation on the spot. If I can do this, even you can do that. But what requires here is practice, and more practice, right? Then 0.9 into 362, 0.9% of 362. Again, 0.9% is 1% minus 0.1%. What is 1% of 362? 3.62. 0.1%, 0.362. So 3.62 minus 0.362 will be how much? 3.24, approximately 3.24, like 3.6 minus 0.36, 3.24. That's it. 3.08 into 3.24. 3 into 3 is 9. 0.8 into 3, 0.24 into 3. So 0.32 into 3. 0.32 into 3 is 0.96. So 3 into 3, 9. 0.8 into 3 plus 0.24 into 3 is 0.96. 9.96 plus 0.08 into 0.24. As I've mentioned, that can be neglected. So 9.96, close to that. 9.96, 10. Though all are close again. I mean, if you really understand 11, I mean 12, 10, 8 seems to be close. But then you must be able to mark 10 as the answer without any difficulty, right? So third option, 10 can be taken as the correct answer. And likewise, there can be questions related to squares. You know, some random number there in decimals, whole square, split a plus b whole square, and apply a square plus b square plus 2ab formula. You have to be really quick. I mean, there's nothing really tricky about that. There's no technique as such in approximation, but then you can apply a plus b whole square expansion and quickly try to get the required answer there. All right. And if, as I've mentioned, one golden rule that you need to remember is, if at all you find any question to be complicated, options are close, and when you look at the question, it appears to be too tricky, the best way to solve that question is just leave it and move to the next one, right? So with this, I would like to close this session on approximations, right? I think we have done enough questions on approximations. Let's close it here. If at all you have any queries, any doubts, you can just write it to faculty@bankerschoice.in.